Okay, so continuing where we left off, I now have some Kmaps over here, and something weird happened to the zeros up here, and I don't know what just, I have no idea what happened to the zero. Something goofy. It's only happening on some of these. Anyway, it doesn't matter. So, to determine the value of J2, we're going to fill in our table based on the present values of Q. So fortunately, so I wrote these in standard truth table order so that now it's just a matter of dropping the numbers onto the board. So J2 in order is 1, 0, X, 0. Then the next row goes X, 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 X. Okay. And so, okay. I was getting distracted. There's a second copy of my mouse on the recorder, and I was like, wait, it won't move over. It's already over. It's on the far left edge. So K2 goes X, 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 X. And for some reason it's decided sometimes to capitalize it. That's just what Microsoft Word decides to do. So there's 0x. Yeah, and then K2 goes 0, 1. Yeah. So it's just a matter of filling the rest of them on. So I'm just reading the columns off one at a time. So there's 0, 0, X, X. The next one is 1, X, X, X in slightly different order, but that's, I'll just throw them on there as fast as possible. X, 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 1, X, X, 0, 0. Then J0 looks like 0x, xx, 0, 1. Lovely. And then, really hope I'm not making a mistake on any of these. And then, oh, this is supposed to say K0. And then K0 goes x1, x0, x, 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 0. Wish I had an easy way to go overlay here. We fill these in. Now it's a matter of drawing our groups, and then we can get our expressions. All right, but wisely, I made sure that these expressions were going to be easy. So they're all going to be fairly straightforward to circle. So up here with J2, we've got to cover our 1s. And so we do it in the largest group the largest group possible, possibly including some don't cares. So J2 groups up like that. K2 groups up like this. Then J1 groups up in a group of 4 like that. K1 goes in a group of 4 like that. J0's group of 4 looks like this, and K0's group of 4 looks like this. Easy to circle. And so then due to our groups here, so we can see that J2 is equal to this group of 4 is simply Q0 bar, because J2 and Q1 and Q2 don't matter, so it's Q0 bar. K2 is just equal to Q0. As we can see over here, Q0 is a 1, J1 in this picture shows as being equal to Q2. K1 is equal to Q2 bar there because Q2 is a 0. That's the only thing that's common in that group of 4. J0 is Q1. And yeah, J0 is equal to Q1, and K0 is equal to Q1 bar. All very nice expressions. Slide that into place. So now we're going to take these expressions over into Logisim and we'll construct them. And I'm just going to pause, and then I'll just pause and construct them and then show them. Alright, and so over here I've drawn the combinational logic using the tunnels, as I mentioned. So in our case, there's no actual logic gates. We just need to arrange them carefully. In general, you will have logic gates on your way between the Q's and the J's and K's. But in this case, it turns out to just be easily drawable in this nice, neat little configuration here. And if we turn on the ticks, then we can actually watch this thing count in the requested sequence. So we'll leave this up for a second. So I've just sent Q0 bar to J2, Q0 to K2, etc. And now I'll sweep this over. Come on. Slide, slide. So there's your diagram. So you can watch it count in order. So it's going to go 0 in a second. Threw me off for a second. So there's 0. Then we're going to go 4. Then we're going to go 6. Then we're going to go 7. Then we're going to go 3. Then we're going to go 1. Then we're going to go back to 0. So that is arbitrary counter design. In general, there will be functions between Q1, Q2, Q0, and J0, and the J's and K's. But this is the idea. We're designing combinational logic to accept the Q's and then perform some logical operation on them in order to control the J's and K's in order to make this work. And it's going to turn out that this particular counter is also very natural in terms of D flip-flops. In general, D flip-flops are often very inconvenient for a counter, but this particular one also works for D flip-flops. So I will also show a D flip-flop variation here in just a second, but I'll cut the video here and then I'll do D flip-flops.